Okay, so I am now going to be talking about our approach to synthesis and integration of evidence. We do, in our assessments, make a distinction between synthesis and integration in the development of our assessments, primarily to ensure transparency in our discussions. The purpose of the synthesis is to describe the types of information within each line of evidence, human, animal, and mechanistic, and to analyze and present the study results for a given health effect to facilitate our integration judgments. The decisions about how we're going to organize a synthesis are made prior to data extraction so that we can focus the data extraction with to help us tell the story of the evidence. These are narratives, but they're not study-by-study summaries, and their purpose is to highlight information that informs the evaluation of hazard. The purpose of integration is to use the information presented in the synthesis to develop judgments regarding strength of evidence for a health effect across lines of evidence. It's a multi-step process, including transparent and structured approaches for drawing summary conclusions. I keep wanting to turn my mic off. Okay. The NAS 2014 report discussed different alternative organizing principles for evidence integration, noting that for iris assessments, the amount and quality of evidence can vary a great deal depending on the chemical. They did discuss using mechanism as an organizing principle, but they did discuss the complexities with that approach given the variation in types of data available, and noted that the history of science is replete with solid conclusions, solid causal conclusions in advance of solid mechanistic understanding. So our current approach focuses first on the available human and animal health effects studies, incorporating mechanistic information at various stages of assessment development to clarify identified gaps in understanding, for example, determining the human relevance of animal model data. The NAS panel recommended that risk of bias assessments for individual studies be carried through the process and incorporated into evidence integration, and we are certainly doing that. The NAS acknowledged that the development of an integration approach would be incremental, but did not offer a preferred method, instead emphasizing the need for transparency. The panel also recommended that EPA expand its ability to perform quantitative modeling of evidence integration. So our current IRIS approach continues to use a guided expert judgment process, but we've developed and defined structured sets of categorical criteria for decision-making within that process. The current frameworks and documentation of our decisions are intended to enhance transparency, reproducibility, and comparability across health effects and assessments. The approaches are evolving in our office, and we are also involved in these developments across the field, which are also evolving. And also with regard to the quantitative modeling, we do have a research program in NCIA that includes projects that are developing quantitative methods to integrate evidence across streams, including Bayesian approaches, and that will be described in a little more detail tomorrow morning. Right, I want to keep doing that. Too many buttons. Our IRIS handbook includes a discussion about approaches for organizing and analyzing study results, deciding how to present the analyses to most effectively inform the issue important for making hazard determinations. And we have come up with a set of questions that we recommend our assessment developers think about when looking at the evidence, primarily to identify any heterogeneity in study results and potential sources for that heterogeneity. Of course, a scientific judgment is central to the process. The synthesis of evidence is more than just counting the number of positive and negative studies, and embedded in the process is to systematically consider the influence of bias and sensitivity when describing study results and synthesizing evidence. And in particular, we aim to primarily base our analyses on medium and high confidence studies when available, acknowledging that there may be some studies that we view with lower confidence that may particularly inform the story because they have maybe unique designs or particular data that we want to discuss as well. And then finally, our analyses try to draw conclusions about the strength of evidence across findings from collections of studies, if we have them. So we use an adapted set of considerations based on Bradford Hill to analyze the evidence, and the issues from the study evaluations, of course, are incorporated within each one of those. Analyzing consistency, of course, is a primary goal for the synthesis. That can include analyzing across categories of confidence in study results, study sensitivity, the direction of bias, exposure levels, and other aspects of exposures that are important for that particular scenario, populations, species, life stage, and other potential explanatory factors. Large effect magnitudes can mitigate concerns about bias. Smaller effect sizes, they're not discounted outright, but looked at in a more focused way. Of course, we do think about precision in studies because that can certainly help out rule out chance as an explanation. But we don't simply exclude those studies. We look at them in totality, try to look across studies, and potentially do meta-analyses. If an expected pattern of response across exposure is observed, this can mitigate some concerns about bias and confounding. Results presented across studies may also tell some information about exposure response, because you might have studies done among populations with lower exposure and higher exposure. And of course, the shape of the dose response curve will depend on the particular outcome. Coherence involves looking at results for related endpoints both within and across studies. Does the entire picture make sense given the biologic understanding of the organ system or disease and expected temporal relationships? For epidemiology evidence, if there are natural experiments to look at, they're important to highlight. And temporality is looked at closely during the study evaluation phase. The informative human and animal health effect evidence is the animal and human evidence are synthesized separately, and mechanistic evidence is synthesized as it informs the conclusions regarding the health and animal health effect evidence and any particular questions that arise. This example for epidemiology evidence is the kind of presentation that we are shooting for. This is from the Report on Carcinogens monograph on trichloroethylene. It's a forest plot for TCE and kidney cancer. And in this case, it was stratified by study utility, which is analogous to our study confidence conclusions. So it certainly shows that there is a pattern across studies for relative risks when they are arrayed by study utility and also arrayed by the anticipated direction of the bias. This example comes from EPA's review of trichloroethylene, again for TCE and kidney cancer. This forest plot is organized by exposure levels observed in the study populations of the studies on kidney cancer. Again, a pattern is observed which strengthens the conclusions in the assessment. For animal toxicology, these graphs were developed for illustrative purposes. They are based on situations that we've encountered in iris assessments and indicate various ways to look at evidence and look at heterogeneity in data for animal studies, including the timing of exposure in terms of life stage, gestational, or as juveniles and adults. For pathology, there were differences observed by species, rats and mice. And then on the right side, it shows a decrease in behavioral function with increasing exposure, but when the evidence was looked at and stratified by the level of confidence, the medium and high confidence studies really showed no change in behavioral function, whereas the low confidence studies were showing a decrease. And this illustrates the importance of integrating study confidence. And I did want to make a note that in our syntheses and analyses, we do look at more granular limitations within the studies. So we may do sensitivity analyses looking at not just maybe high and medium confidence versus low. We may look at studies that evaluated a particular important confounder versus those who didn't, compare those studies, or studies that may be more at risk of exposure misclassification compared to those that had more robust exposure assessments, that kind of thing as well. And Catherine is going to talk a little bit more detail about our synthesis for mechanistic studies.
Okay, thanks, Barbara. I don't know, I only have 5 slides, so I don't know if you want to stop now or you can continue. Okay. So I'm going to talk about mechanistic information. When the NAS report, in 2014, the NAS recommended that IRIS include systematic review of mechanistic evidence as a part of its systematic review of human and animal evidence as well. But mechanistic evidence presents quite a challenge for systematic review. And this is because the mechanistic evidence is typically both numerous and diverse. They're very large databases made up of many different types of studies. And when evaluating this evidence, it definitely includes all in vitro studies on a chemical and related to the chemical's toxicity, but can also include evidence from in vivo studies and ex vivo studies, as well as the vast amount of information coming from toxicogenomic studies that are increasingly conducted now. So as the NAS acknowledged as well, there might be hundreds of these studies. In my experience, it's sometimes thousands of these studies that are identified as supporting studies in the initial literature search and screen. And not only is the size of this database add to the complexity, but also the fact that for any given chemical, there may be multiple mechanisms that are involved in causing a toxic effect and leading to the adverse outcome. And so the key for dealing with the systematic review of this type of information is really to take an iterative, stage-by-stage approach at narrowing the focus for mechanistic evaluations to those which will have the greatest impact on the assessment and the determination of toxicity from human and animal evidence. So this is especially important, for example, for a chemical that has a very robust human database with high confidence studies. You may not need to conduct an evaluation of mechanistic evidence, or at least a very minimal one. But conversely, when human data are non-existent, are mixed, or consistently show no association, and an animal study finds a positive association, the importance of mechanistic data is greatly increased. So in order to narrow the scope of these analyses of mechanistic information, we apply this iterative approach to identify key mechanistic questions at various stages of systematic review. So this really begins with problem formulation, identifying predefined analyses. For example, if a chemical's suspected or known to be, or by other groups is determined to be a mutagen, then that's obviously going to be an important thing to begin analyzing right away. And that can be a driver for the assessment in terms of both hazard and dose response. There's also some information that comes from our stakeholders in the scoping phase as well, and what values are most important for deriving for the assessment. In addition, the literature inventory that Andrew discussed earlier, this identifies and organizes the mechanistic data into usable groups that we can then use to facilitate not only further analysis, but also facilitating comparisons, looking at read across information from other chemicals. And in addition, these inventories can identify both gaps in data or areas that haven't been studied, but also can identify areas where there are quite a few studies on a particular mechanism that aren't well represented from the human and animal database. And so these are important to recognize, but it can also give you a sense of how quickly these evaluations can really expand beyond the focus. So it's a constant struggle between identifying mechanistic information that is indicated by the best science, but then also really focusing in on what's absolutely needed for the assessment. And then ultimately, it's the human and animal evidence syntheses that will then flag the most impactful qualitative and quantitative analysis. So, the wrong button. The human and animal evidence will indicate areas in these evaluations where questions remain regarding the toxicity of a chemical, and in this way, I think that maybe you've gotten this from the previous information in these talks, but we don't conduct separate evaluations of human, animal, and mechanistic in a vacuum. These within stream evaluations are constantly informing each other and feeding into each other. And in particular, mechanistic evidence is very important for informing the within stream animal and human evidence evaluations. So in mechanistic evaluations can identify precursor events for humans, and also inform susceptibility in identifying at-risk populations or life stages, and can also answer questions regarding differences seen, for example, in animal evidence, if there's different responses in different species or strains, or between male and female. This can be useful to then feed back into that evidence evaluation in animals. They can inform the human. They can also provide information on biological plausibility and how relevant the animal data is for human effects. As well as providing evidence of coherence and how mechanisms can be interrelated across hazards and potentially across streams of evidence as well. It can also inform extrapolation decisions and characterize uncertainties. So I've offered a couple examples from IRIS assessments that really show how we've been able to focus mechanistic evaluations in the past. So for benzoylpyrene, which was reviewed, a draft of which was reviewed favorably by the NAS in the 2014 assessment of iris. We were able to establish that biological plausibility by identifying a precursor in humans exposed to mixtures of PAHs that was specific to benzoylpyrene, therefore allowing an association to be made between exposure and effect. For dichloromethane as well, it's a slightly older assessment, but we focused on a susceptible genotype that was identified that then informed the cancer risk estimate. And so these assessments aren't new, and they certainly represent very early stages of systematic review that were not where we are now. But I think they really provide good examples of how this focused approach is effective, and that moving forward in the future, the real how we can really advance in terms of systematic review is by documentation and transparency for all of these decisions made for future mechanistic analyses, including evaluating mechanistic studies. So the NIS also recommended that implementation of study evaluations, including risk of bias and toxicologic relevance, be extended to in vitro studies, while acknowledging the real difficulty in doing this, and that there aren't currently any tools available to do this. So in our process of focusing on particular focusing the mechanistic analyses. Once we get to the stage where we've decided the key areas to focus on, triggered mostly by the human and animal evidence analyses, we can then prioritize those studies of relevant endpoints and associated assays by toxicologic relevance. For example, by model system, dose range, and the other criteria listed here by the NAS. And at that point, then, when we've identified the areas of focus and then prioritized the studies investigating those endpoints, then we can conduct individual study evaluations on the most impactful studies. So right now we're exploring the use of using existing tools for assessing risk of bias and sensitivity, including adapting current tools that we're using for evaluation. Obviously, if there's a human or animal study that is presenting mechanistic information, we already have tools in place that can provide some level of documentation in the same fashion. But for in vitro studies, it's a much more complex question, and we are working with other groups that are interested in this, including OHAD and CIRAP, that have been thinking a lot about how we could potentially start moving into this area. But I think ultimately, as long as we're transparent about the decisions we make and the studies that we choose to focus on, all of that information will be clear in the assessments. And we will continue to use organizational frameworks, including those put forward in the cancer guidelines based on modified Hill considerations, as well as taking some of the lessons from the use of adverse outcome pathways, using those visualizations that can really provide an effective way to show connections between key events, and then how different mechanistic events can interact to lead to the adverse outcome. And ultimately documenting these analyses in a transparent way, using these frameworks, can then convey conclusions for evidence integration. And that's what I will then pass to Andrew.
So let me just ask that we try and finish up relatively quickly so we have adequate time for committee discussion. So perhaps, I know you still have some fairly dense stuff to get through here. So
about 10 minutes?
Max, thanks.
Okay, I can do that. You heard how fast I talked in the first session, right? So now transitioning or moving on from evidence synthesis to integration, as Barbara introduced at this step, what we're doing is we're taking the outputs of the synthesis of the 3 lines of evidence, so the human, the animal, and the mechanistic studies, and those become the inputs for our evidence integration. And here we're drawing summary conclusions across all the evidence, or all 3 lines of evidence, using transparent and structured processes. Now for evidence integration, we're using structured frameworks that rely on a sequential 2-step process. In step one, we're drawing within-stream conclusions that judge the strength of the evidence for both the human evidence stream and separately the animal evidence stream. And then in step two, we're drawing an overall conclusion based on a cross-stream integration, so integration the human stream with the animal stream. More specifically, in step one, when we're making that human evidence stream judgment, what we're doing is we're characterizing the strength of the evidence from human studies. This would be the human health effects studies, as well as any mechanistic information in human models. Separately, what we're doing for the animal evidence stream judgment is characterizing the strength of the evidence for an effect in animals. Again, animal health effect studies and models in animals. And then in step two, we're integrating those judgments for the human and the animal evidence stream in light of inferences, mostly mechanistic, such as what is the relevance of the animal data to humans? Was there coherence in the findings across the human and the animal evidence stream? Were they finding biologically related or similar findings across those evidence streams? And what information on susceptibility do we currently have? And the reason for doing this in a two-step process is to be really clear and transparent about the rationale for every step leading to our ultimate judgment, which we've been hearing from the NES since 2011. So to draw these within-stream evidence judgments for both the human and the animal evidence stream, as Barbara introduced, we use adapted Hill considerations. And for this, we had to develop criteria for how to evaluate each of those considerations. And so we've developed criteria for when the evidence is strengthened or weakened based on an evaluation of each of the Hill considerations. Of course, implicit within this, as Barbara introduced, is the evaluation of individual studies. So for each Hill consideration, we take into account, and actually has a large impact, is the quality of the studies for informing those different considerations. And so we prefer high and medium confidence studies to provide stronger evidence within the evaluation of each Hill consideration. As an example for consistency, to strengthen the human evidence stream, we would say we'd want higher medium confidence studies that were observed consistently across diverse populations. For animal studies, we would say we want higher medium confidence studies observed across different animal species or across independent laboratories. And of course, the converse of this is also true. The opposite of this is also true, in that if we had a set of studies where there was unexplained inconsistency, this would probably reduce the strength of those evidence streams. And so we developed this for all of the Hill considerations here, and as shown in blue are how the mechanistic information informs our interpretations of coherence and the mechanistic interpretations relating to biological plausibility that Catherine just introduced. So then once we have made those judgments or those evaluations for each of the various Hill considerations, we apply these within structured frameworks for the two-step process. So in step one, we've developed these example-based categories or strengths of evidence for both the human and the animal evidence stream, ranging from the top there, the strongest evidence supporting an effect, all the way down to the weakest evidence supporting an effect, or even evidence supporting lack of an effect. And then for each of these, we've developed these example-based criteria. For example, to reach the strongest evidence judgment, you would have to have a set of consistent, high or medium confidence, independent experiments that reasonably ruled out alternative explanations. To reach that judgment for the human evidence stream, this consistency would have to happen across diverse populations with clear evidence of a dose-response relationship. To reach that same conclusion for the animal evidence, it would have to be consistency across independent laboratories or species, as well as multiple levels of additional support. For example, the data has clear evidence of a dose-response relationship across the studies, as well as a well-supported mode of action. And again, we've developed these example-based criteria so we can say where the human or the animal evidence falls in terms of those different categories or levels or strengths of evidence. We then do a similar thing in step two, where we take those judgments from step one for both the human and the animal evidence streams, which we document so people can see the rationale for those decisions, and developed a similar framework where, again, we're ranging from these different example-based categories from the strongest conclusion for a human health effect down to the weakest conclusion for a human health effect, or even strong support for lack of a human health effect. And again, we have these example-based categories. For example, to reach the highest evidence conclusion, we would have to have the strongest evidence judgment in the human evidence stream, so for example, convincing human evidence, or a less strong judgment for the human evidence stream alongside of the strongest evidence judgment for the animal evidence stream, and understanding that those animal findings are relevant to humans, which is obviously consistent with our cancer guidelines. And so we've done this for all the categories here, so we can define where the data takes us pretty easily, but it allows flexibility for expert judgment. We're just documenting the expert judgment and providing a transparent mechanism for having conversations during public and peer review on those judgments with the specific rationales, rather than using an algorithmic approach that says, you're going to wind up here. So that's just the criteria for how we make these judgments, right? Which is nice to have, but if we can't document that in a clear way for the public, we can't have those important conversations. And we've heard this from the NAS in both 2011, that we need to be really transparent in defining what were the different aspects of the evidence that resulted in our ultimate judgment. And so they give the example of, consistency. The whole consideration of consistency was really the reason that you arrived at this, likely to be carcinogenic conclusion, that you should emphasize that consistency was really the driver of that conclusion. And they suggested the use of templates to support the evidence integration narrative in order to more transparently convey these decisions. So we've taken that to heart, and we've developed and are applying these evidence profile tables to support the evidence integration narratives. This is a template version here, and we hope to be rolling this out relatively soon. And to dive in a little more deeply, what this does is it basically lays out all of the studies as well as our rationale for each step of the two-step evidence integration process and how we arrived at our ultimate conclusion. This would support the narrative text summary as well. So diving a little deeper, there's two rows there shown in blue. One is the human evidence stream, one is the animal evidence stream. We describe the set of studies in that left-hand column as well as the study evaluations, what were the general strengths or weaknesses of that set of studies, and then looking across that body of studies, for example, the human studies, what are the factors, those Hill consideration evaluations that either increased or decreased the evidence strength. And this would not just be a one-word answer, it wouldn't just be the data were consistent, it would be the data were consistent based on studies X, Y, and Z that showed yada, yada, yada. Right? And then we'd summarize those findings across a set of studies. We might decide to subdivide this row. That's what that yellow text is saying that you can't read there. That's saying there may be multiple decisions, for example, for the human evidence stream. If you see that your results are different across life stage, for example. I think that was one of the examples given. If you're seeing effects with developmental exposure, but you're not seeing effects, with chronic long-term exposure, then you might make two separate decisions there regarding the human evidence stream. So summarizing the findings for within stream for each of those rows. That second to last column is the rationale for the inferences across the evidence stream. So, for example, the relevance of the animal findings to humans. And then that right-hand row is a summary of the overall conclusions. Now, these conclusions culminate in an evidence integration narrative for cancer that also includes a descriptor for carcinogenicity, as all of you are familiar with, carcinogenic to humans, likely to be carcinogenic, et cetera. For non-cancer, while we've developed these frameworks and are applying them to add structure and transparency to the evidence integration narrative, we've not yet incorporated standardized descriptors for non-cancer health effects. The NAS in 2014 did recommend that we make incremental improvements in this area, and we are currently discussing within the EPA across programs the way in which these conclusions are summarized. And then the last slide is just, again, the summary of the topics covered in this session. I would emphasize our established process for evaluating individual studies, as well as our transparent and structured frameworks for synthesizing and integrating the evidence. There are a number of posters and demonstrations this evening I draw your attention to. I think most notably Xavier mentioned the phthalates posters. That's a set of 4 posters that walks through male reproductive toxicity in epi studies, animal studies, mechanistic studies, and then has the evidence profile table that summarizes across those 3 lines of evidence. I also did want to clarify, I should have clarified at the end of the last session, is that this table has process improvements that address the recommendations, but they're not necessarily all new. They're just, if there are things that worked in 2014 that we think still address the recommendations, that we had in 2014, we've included them, but they're not all necessarily new. So with that, I think that was 8.5 minutes-ish.